So welcome back. The second method for your collision-free protocols is binary countdown. Okay, so we try to understand how binary countdown method works. Okay, so as you all know that this will help you to understand the topic in an easy way. So let's get into it. For example, points to remember to this specific method is, first of all, you have to provide addresses for the stations that are transmitting the data. So in my example, to make it more clear, I am taking total number of 10 stations. Okay, assume that the name of the stations are A, B, C, D, E, F, G, H, I, J, K. So till J, okay, till J I am taking. So 10 stations are available. So when I say addresses, assume that to provide addresses for these stations, you have to check with the value. Like for example, if you want addresses for 2 stations, you just need 0 and 1. That is fine with 2 bits. If you want addresses for 4 stations, then you need 2 power 2. If you want addresses for 8 stations, you need to go for 2 power 3. Now there are 10 which is greater than 8 and less than 16. So I need 2 power 4 bits to provide address for these stations. So every station will have 4-bit addresses. Okay. So for example, station 1 which is 0001, station 2 0010, station 3 0011, station 4 0100, station 5 0101, station 6 0110, station 7 0111, station 8 1000, station 9 1001, station 10 1010. So I have provided addresses for the stations. So now let's get into the topic how this binary countdown will work. So assume that in this example my station B, and we'll pick some stations like how they'll be working and all. I'll pick station 4, I'll pick station 9, and I'll pick station 10. So assume that these 4 stations wants to transmit the frames, and remaining stations are not interested to transmit the frames in this time slot. Okay, now the point is how to choose the station and how to decide which station will transmit its frame first from the information available. Okay, so let's get into this. So now what I am doing, I am taking those 4 station addresses 0010, 0100, 1001, 1010. Now let's understand. These are just the addresses of stations which wants to send their frames. So this is frame related to A, this is D, this is I, and this is J. Okay, right. So how to identify this? Now there is a mechanism to identify this one. That is, we have to pick all the higher order bits of the addresses. So you all know that, right? This is the higher order bit and this is the lower order bit for every address. So most significant bit and least significant bit. So higher order, lower order. So what I'm doing is I'm picking all the 4 higher order bits outside. So 0, 0, 1 and 1. Okay, I have just picked up all the higher order bits of the addresses of those stations which wants to send those frames. So from these values I am performing OR operation. Okay, if I perform OR operation, I'll get value 1. That's pretty simple. Remember that you're going to pick out the most significant bits of all the addresses, and then you are performing OR operation and you'll get 1. means in this round, in the round 1, only those stations can participate which are having 1 as those higher order bits. So ఈ రెండు మాత్రమే participate చేయగలవు because they have 1 in their higher order bits. So these stations will come into picture because the value is 1. So now from these two stations, so this is, assume that this is round 1 and round 2. I got two stations, but I have to decide which station will send first from these two stations. So again, you are going to pick the most significant bit. Now this proves that both are 1, obviously. So you'll go to the next higher order bit, that is 0 and 0, which brings you nothing. You'll go to the third one, okay? You'll go to the third bit where you'll be getting 0 and 1 and your value is 1. If you perform XOR operation, your value is 1. So again, in iteration 3, that means iteration 1, iteration 2, iteration 3, iteration 4, like this. Okay, so third iteration, it will choose which station is having 1 as a value. So only one station is available. So by this it is decided. You don't need to go for the fourth one. Okay. So among these 4 stations, the first station which is going to transmit is J. That is 1010. A station with address 1010 is allowed to transmit the data first. So this is the first station. Okay. That is allowed to transmit the frame. Obviously, if you assume that this is round, okay, round 1, to choose which station will go. Now if you perform the same operation with round 2, so obviously this station is no more available. This is decided unanimously that this is going to send the data. Now you have A, D and I. You all know that in round 1 itself we have decided this station wins in the race. Okay, because the first bit itself is 1. So obviously station I will be allowed to transmit its data in the second position. So second station which is allowed to transmit is this one in round 2. When go for round 3. Okay, so now coming to these 2 stations, leftover stations are migile naku. So as you all know, if you go for the higher order bits, these 2, then obviously this won't bring you anything. You will go for the second position bits of these 2, 0 and 1, where in the second higher order bit you get D as a choice, which means what is the address of D? It is 0100. So third position, which is my third station, will be D. And obviously in round 4, the leftover station is A with the address 0100. In a short, I am repeating it once again. From the available stations, we are providing addresses. And these addresses is nothing but based on the bits you are choosing. So if you have 10 stations, you will go for 4 addresses, 4-bit addresses. So I have assigned addresses to all the stations, and stations that wants to transmit frames, I am pulling them out. I am writing those addresses over here, and I am comparing all the most significant bits over here and performing OR operation. So if you receive 1, you have to choose those addresses that are having 1 in the MSB locations. So I am excluding these 2. I am considering only these 2. Out of these 2 are here. So I will be going with the next higher level and then next higher level. So I choose J to be the first one to transmit the data. And again I. Out of these 2, in the second bit position, D got a chance to win. So round 3 will be D and round 4 will be A. This is how your binary countdown method works.